What is this? You can see it.
Yes, Tulsi, we can. One moment. Tulsi, can you see me? Yes. Yes. I'm ready, Tulsi. Check Mr.
Yes, sir.
Samir and Prajot or everyone is ready.
We are ready to go, sir. All done.
Yes.
So we are ready to go, sir. You can start, sir, now.
Okay. Welcome everyone to the Vikatan Automotive R&D Design online workshop. It is very actively and dynamically supported by Mahindra RISE. Today is the fifth and final day of this very engaging workshop. To say the least, we are very excited, both Vikatan and as well as Mahindra. The response we have received from you is phenomenal. More than 16,000 people registered, and session after the session, you people attended not only in the Zoom and also in our other platforms like our YouTube channel and also our microsite. And the way in which you are engaging the speakers is very heartening. And of course, to say the least, it's raining questions all the way. So we haven't seen this kind of active, but dynamically active participants like this. We are really, very happy to interact with this kind of students. And today we have Mr. Samir Rawte. Mr. Samir Rawte is here. Of course, he doesn't need any introduction in the field of automobiles, because if I say that, you might have seen his works on the roads. I think you people, sure have seen the Marazzo and also the vehicles like SUV 500, which is an iconic product in the Indian roads. So his involvement and his contribution in making these products is very huge. And I think today we are very fortunate that he is going to share his experience in making this kind of vehicles. And I just like to thank Mr. Veluswamy sir, who is the head of the global product development design. He is the one who inaugurated this workshop, and he dwelt in detail about the roadmap to our aspiration to the world of automobiles. And Mr. Michael Smith, who is the chief platform head of Mahindra and Mahindra, spoke about and enlightened us about the e-mobilities and future on the first day session. And Mr. Naveen Chopra, the chief platform head of platforms 3 and 4 of Mahindra and Mahindra, shared many details on co-creating automotive product development. And Dr. Akila Sharma, of course, that was a very interesting session for everyone. You people, engaged him with your questions. And he spoke about the importance of simulation. It was very exciting to see his visuals. And last Saturday, it was Dr. Shankar Venugopal. Of course, he spoke about innovation, creativity of automotive engineers. Of course, even before he spoke, even we people as journalists doesn't know engineering calls for that kind of creativity. So today, Mr. Samir Rawte, of course, I'm just curious to find out about his profile, because even when I found only then I found out that it's the name itself sounds warrior. So he's a horse warrior. That's what his name means. That's what the given name means. So he is also, of course, the vehicles, be it Marazzo or be it SUV 500, we have horsepower. The horsepower, unlimited horsepower. So we are going to listen to a person who has made the horses inside this SUVs to roar. And Samir is a chief engineer in the global product development team of the Mahindra Research Valley. Of course, he started his career in Mahindra, and he is a very long time at there. I think after passing out from the college, he joined Mahindra as a product development team. Since then, he is with Mahindra and Mahindra. So that is the strength he has got. He has worked in all the systems of automobile from concept of productionization, which has helped him to develop an expertise in the area of vehicle architecture and platform development. He was the project leader of the shark-inspired Morazzo, as I told, and also the cheetah-inspired iconic brand SUV 500. Samir also led the Center of Excellence for Advanced Engineering and Vehicle Architecture, was instrumental in developing the architectures and platform of all Mahindra brands. His current assignment is Chief Platform Head for Born Electric Programs. What is Born Electric Programs? Some people are born as warriors, and some people, convert as warriors. So like that, I think, of course, let us wait for Samir to tell what is the Born Electric Program. Mr. Samir, sir.
Good morning. Thank you, Mr. Wills.
Yes.
It is an interesting introduction that you have given. I mean, I'm honored, and I have immense pleasure to be interacting with a lot of students. And I like interacting with students because when we started our career in colleges, at that point of time, interaction with industry was not that much. And most of the times we wouldn't get to know what exactly happens in industry. It would only happen when you kind of go for an industrial visit, wherein you could meet up with professionals, but it would be a very short duration visit. So what goes on in a big OEM, automobile OEM? I mean, it's a very good initiative between Motor Vikatan and Mahindra to inculcate these kind of education series for all the students, and be very helpful for most of the people. And for us also, it's also good that we are able to share our experiences that we have learned over the years. So I'll start with my presentation. Are you able to see my presentation, Mr. Wills?
Yes, sir.
Yeah. So automobiles, I mean, Mahindra and Mahindra is in the 75th year of its being in existence and making automobiles. So automobiles have been in use for a long time in the world. And these objects are actually primary means of, you can say, transportation of people and goods, both for recreational and commercial use. These automobiles have evolved over the years. In fact, the earlier automobiles, when they started, they were basically objects of mobility. The prime focus was mobility between point 1 and point 2. Today, the vehicles, automobiles have become aspirational. A lot of technology is infused in them, and they are actually objects of desire. And Mahindra is in the business of both the objects of mobility as well as the objects of desire. Some of our vehicles, people really aspire and desire to use these vehicles. So automobiles have grown over a period of time, and the design and engineering of automobile is a very elaborate, methodical, collaborative process, which involves a lot of experts. And these experts come into something which is called as a common purpose teams. And these experts are led by chief engineers to actually conceptualize, build up products, and then launch them into the market. I believe in the earlier sessions, you would have understood about how these teams work and how this process goes about. So today, my focus is going to be in terms of how do we create that concept to the engineering, which is basically the vehicle architecture, right? And the starting point for this vehicle architecture, actually, if you see in automobiles, is it's actually a self-propelled uh, unit for people. So the center point of any automobile design is nothing but the people who are going to use the vehicle, right? So understanding the latent desires of these customers, the market, and integrating new technologies and manufacturing considerations are key factors which hugely influence the design, engineering, manufacturing of automobiles. So my presentation today, which is split up in these 5 points, will explain how this collaborative process got the common purpose teams together to define, refine, and develop iconic brands like Bolero, Scorpio, XUV, Thar. What I have done is I've tried to put together the amount of information in a way in which it will be very simple way the students will be able to understand this. Okay. So now let's get to what is the anatomy of an automobile. Okay. So if you see on what you see now is actually one of our vehicles, which I have shown with a lot of, you could see key elements, which an automobile engineer needs to really understand before he gets into actually designing a vehicle. Okay. So automobile is nothing but, if you see, there is a propulsion unit and there are people sitting inside the vehicle. The propulsion unit is drives the wheels, and the driver controls the amount of power which gets to the wheels, and the people inside, are able to move from point 1 to point 2. So if you see, the prime focus of all the vehicle design is of the people who are sitting inside, and rest all other aspects or elements which get into designing the vehicle are kind of elements which perform certain functions. So to master the art of packaging, a good vehicle architect needs to understand proportions, because a vehicle needs to look good. I mean, everybody appreciates Cheetah, the XV300, XV500, Marazzo, and the latest vehicle that we have launched, Thar. They are very a unique design and looks to the vehicle. So proportions play a very important role, because they are the ones which attract the customer to the product. And functionality and performance is the other aspect which needs to be considered. Functionality and the performance is something which is kind of plays a secondary role, but it's a very important role. The proportions play a very important role, which is in terms of the way the vehicle is dimensioned, the way the vehicle it looks like. Okay. All other systems, if you see the ones which I've mentioned here, like for example, powertrain, then your wheels and tires, the occupants sitting inside, all are packaged within a space. Okay. This space which we have packaged has to consider movement. So there are movement of wheels, there is movement of powertrain, there is movement of drive shafts. So they have to be considered. There are manufacturing tolerances which need to be considered. There is isolation which the occupants or the people sitting inside have to be considered, so that they are completely protected. Importantly, for the manufacturer, it's very important that the manufacturer is able to assemble the vehicle in a shortest possible point of time. And in terms of any eventuality, you should be able to service the vehicle. So a key role of a vehicle architect is to ensure that he minimizes the compromise between the design and the functional attributes, and allows a degree of freedom to all the engineers. Okay, so this is the key aspect of any architect to start designing a vehicle. Now, each and every part which I'm showing here performs an important role. Like for an Indian context, if you see the approach angle, the ramp breakover angle, ground clearance and departure angle play a very important role because of the inherent road conditions that we have, and we need to protect ourselves. Okay. Now, this is how a vehicle looks like when after it is configured. So this is what you will see, but not what we start with. Okay. Now I'll move to vehicle systems. So the key on the vehicle systems is all functional attributes. These functional attributes are actually coming in from what the market demands and the customer demands are. For example, if you see powertrain, it's all about power and torque. It's all about what kind of fuel that we use. It's all about what kind of drive means we use, automatic, manual transmissions, AMT. Okay. Nowadays, we see also electric vehicles coming in. So the key aspect here is a powertrain. The next aspect, which is very critical, which is important, which occupies, it takes more space, is the comfort part of it. So if you see tires, suspensions, they play an important role. Okay. Now, when it comes to occupants, they are the prime people or the prime movers for the vehicle conceptualization and design, because we are designing the vehicle for them, right? So how many number of people to sit inside the vehicle? What is the luggage space that they're looking for? Okay, so these are certain aspects that they need to be considered. Now, when the occupant sits inside the vehicle, he needs to interact and interface with the vehicle. So there is an infotainment system, there is a display systems, there are controls. So each and every part of the vehicle, if you see, is being made by multiple experts. Now, each of the systems that you see here are called experts, and they are led by a center of excellence within a PD function, is what you would have gone through in the earlier presentation. So I'm just telling you how this center of excellence is, collaborate to build up the vehicle. Okay. So the key aspect here is these are the systems which actually are the attributes and drive the functional performances. Okay. Now let's start with the vehicle architecture. Okay. So what do we mean by vehicle architecture? So if you see here, I just took that same image and I split it up into 3 areas. Okay. The first area, which is the prime area where I think we discussed earlier, was the occupant architecture. I mean, this is the box where the occupant would be in the vehicle, and the whole vehicle actually gets designed there. Okay. The most important aspect here is all about space. It's all about comfort. It's all about visibility. It's all about, luggage room. It's all about what kind of features we can give to ensure that there is comfort and convenience inside the vehicle. Okay, so we will, in the next consecutive slides, learn about how occupant architecture is built up. Okay, the next box, which is on the left-hand side, which is all about the powertrain architecture. Now, I have taken an example of a vehicle where the powertrain is in the front, so we will be talking about that. But there are multiple locations for powertrain. So a powertrain architecture talks about everything which is got to do with what the powertrain is all about. What is that prime mover that we are trying to look for? So it could be a diesel or a gasoline engine, low power torque, engine with a different capacity, a small engine, a 2-liter engine. Okay. This particular architecture is driven by, like I said earlier, packaging of a powertrain, lot of dynamic movements, and requirement for thermal, requirement for NVH, and requirements for good assembly and serviceability. So this is where the functional unit comes in. As the world is progressing towards electric motors, you would see that the space demand for the powertrain reduces. Okay, so this is what we see today. Now, the third box is the underbody architecture. Now, this is where something, your energy source, which is either in case of an electric vehicle, it could be a battery there. In case of a gasoline vehicle, it could be a fuel storage there. I mean, and suspension, all your drivetrains, and spare tires. These are parts which get accommodated there. Okay. So when a vehicle gets designed, right? So the most important aspect is all of these parts are kind of have to get into the volumes that I have shown here. Okay. Now, how does this process happen? Because what you see on the screen is something which is, already done. So how did it start with? Okay. So it's the first point that it always starts with is an occupant packaging, because the vehicle has to be, the concept of vehicle design that is being followed in the industry, and Mahindra also follows this, is called an inside out packaging. The inside out packaging focuses more on the customer space, because he is the person who is buying our vehicle. So, and he is the one who is going to be looking at the comfort and the convenience there. So the whole design starts with the customer. Now, the most important point of a design to start with, I've shown here market segments. There are luxury cars, minivans, off-roaders, SUVs. You see most of the Mahindra vehicles here, right? So this starts with actually the market segment that we need to get the product for. So I would say that, okay, we are starting with the SUV market space. So the concept that any automobile manufacturer tries to work with is a multifunctional concept, so that he is able to leverage that product in multiple segments in the market, so that he is able to leverage all the investments and the cost. Okay, so for every concept, the most important purpose is customer, manufacturer, and the market. Okay, so we have to keep this in mind. So for customer, what is important? So it's brand identity important, interior space is important, towing capacity, getting in and out of vehicle is important, maneuverability in the Indian context, to be able to turn the vehicle in very sharp turns, very small turns. Safety and crash worthiness, Mahindra is now by leading in that. If you see, most of our Mahindra vehicles are having good crash ratings. And most of all, what the customers basically look for is trim, colors, varianting, features. Okay, so these are certain things that are what in the ideation process, in the initial process, is what the concept team studies about. Okay, they also look at segments of vehicle. So aftermarket and the market segments, we start with the prime occupant definition. So if you see a person who is going to use the vehicle, right? He needs to be considered into the vehicle design, and his needs have to be considered into the vehicle design. So how does his need get considered into a vehicle design? So the first and the foremost need of a person is to define who that occupant is. And one of the ways in which people define an occupant is by his size, okay, by his anthropometry data. So what do we see here? I mean, in this scenario, the most important thing is, if you see, if we are designing a vehicle for the global market, now we need to then in that case consider, consider a wider spread of people. And we need to consider from 5th percentile till 95th percentile a person for accommodating into the vehicle space. So that will then define the vehicle space. Now, most of the global OEMs have this anthropometry data, and Society of Automobile Engineers have released these standards, and they become as a guiding principle for many automobile designers. Okay, these mannequins are 3D mannequins. Okay, so when you decide the market and you decide where the automobile needs to come in, it's also important to look at the target population that you need to get in. Because the kind of market that you're looking for, whether it's a luxury vehicle, whether it's an entry-level vehicle, these are certain aspects that you need to consider. After that, the most important aspect which comes in is your digital person. He is called the mannequin. Many people name the mannequin, and this mannequin has there are various softwares now available with global OEMs, including Mahindra's, where these mannequins perform the task what a person would do inside a vehicle. Okay, so these mannequins, if you see, there is an anthropometry data. This anthropometry data is reflected by the digital mannequin, his height, his upper body torso dimensions, lower body torso dimensions, his eye points, everything is digitally available. And these are the ones with which the vehicle design starts with. Okay. Now let's get to how, once you have decided that the vehicle needs to be in the global space, the vehicle needs to be an SUV that we are looking for, or it could be an off-roader. So we are assuming that we are going to design these two vehicles. The most important first aspect which comes in is at what point would you want to, would you want to place the mannequin in your virtual layout? This is where the work actually starts. Okay, there is no person who is there who is saying that now I need to be here. So it's all the digital mannequin, and all the work which happens through is through digital mannequin. So what we do here in that case is there are two aspects here. If you see, I have shown here from a sports car to a truck, how a person's posture is built up. Okay, this posture is very important because from this posture, the comfort aspects of the people who are going to use this vehicle are going to be assessed. Okay, the prime focus here is to ensure that he's comfortable and he's also safe. That's the most important part first. Now, if you notice, there are two dimensions in an automobile industry which are very critical. One is the H30, which is H is in terms of height, and H5, which is in terms from the ground. So if you see in an off-roader, Mahindra Thar kind of a vehicle, the person sits quite high from the ground. And he also sits quite higher from the vehicle floor. The intent here is basically because he should have a better visibility. The most important intent is we need very high ground clearance because the vehicle has to negotiate tough and undulating terrains. So these are certain things where you need very high ground clearance, and the tire movements have to be very high. Okay, so that the occupant then is made to sit up. Okay, and also the powertrain, because since these vehicles are going to be very powerful, the engine capacities are going to be very, power and torque will be very high. So the size of engines are also big. So they also need to be placed up. So if you see, the ground clearance goes up, and for better visibility and good drive on off-road conditions, these are high sitting positions. So this is where the first definition point comes in. Now, industry-wide, each company has their own trust marks, which is called their knowledge base, which they have gained over a long period of time. And these trust marks are built up on the, you can say, the brand identity, in the sense that a company like Mahindra always tries to have a higher sitting position. Okay, a commanding sitting position. It's actually called a commanding sitting position. So you'll find that these dimensions for a company like Mahindra will be on the higher side. The focus is more to, have a good ground clearance and off-roading condition. Okay, so this becomes the initial concept of the layout. Now let's move to how the driver. Now the most important person in a vehicle is going to be your driver. Okay, why the driver is important? Because he is the one who is actually controlling the self-propelled vehicle. Now, yeah, in the latest context, we have your autopilots, but still you have a driver who holds onto the steering wheel. So the driver plays a very important role in terms of, controlling the vehicle. So for driver, it's very important that we have to ensure that he has comfort and safety, but most importantly, he has a good reach for all controls. Now, in any vehicle design, if you see, the most important part is the position of the driver, which is this point where he sits. This particular point is called the H point. Okay. And from the H point, the key aspect is to have foot controls on the lower limb of the body, which is your pedals. Accelerator pedal is the pedal which is continuously used. So the focus is on the accelerator pedal. But most of the time, the clutch travel is more. And the clutch travel actually defines where he sits into the vehicle. Okay. But this is how the first accelerator point gets defined. So your H point, accelerator point, and steering point. Your upper body, which is this aspect, your lower body, which is this aspect. At no given point of time, you should be stretching yourself to reach for starting of control or end of controls. Okay. So this is how this aspect gets defined. So you need to know clutch travels. You need to know where the steering position should be. And you need to know from this point, where do you want steering and this to be within the comfort range, because you would want this to be comfortable. Now, companies have, again, trust marks. They have their own standards. And there are also legislations which drive this. For example, from steering wheel to your chest, airbag deployment plays a very important role. Okay, so there has to be a bare minimum dimension which needs to be coming in. From IP to instrument panel that you see here to your foot, you need to have good clearance there, because you wouldn't want that this legs goes and hits this in times of an accident. And your pedal movements should be such that this leg is not stretching. Okay, so this is how their first triangle is established, and based on your company standards and guidelines, a lot of benchmarking and a lot of you can say studies happen to define and refine these points. Once this basic point is defined for the 95th percentile, which is the tallest mannequin that you need to do in, you need to also work through and ensure that the shortest mannequin also get in. So if you see the 50th percentile, the 5th percentile, all of them should be able to get into and accommodate within this so that they are comfortable within the vehicle. Worldwide, nowadays, if you see, a lot of features are given. You have seat tracks, so which can help. You have seat height adjustment. You have seat recliner. You have steering tilt and telescopic. And in some vehicles that I have seen, you even have adjustable pedals. Okay. So your first aspect of any vehicle design is your driver space. So defining driver space and ensuring that this particular triangle, which we call it as the strategic driver triangle, is first established. Okay. Now moving to the next point. Now the key aspect here is, since we said that we will design an SUV, so we'll move to what happens to the second and the third row. In the second and the third row, it's very important that the occupants need to have good space and comfort for themselves. So one of the aspects which is considered in an automobile industry, which is called as a couple distance. So your first point to the second point, if you see here, is actually called the couple distance. Okay, from this couple distance between the three rows of the seat, the whole work which is happening inside designing of the vehicle is purely focused on comfort for these three rows of people sitting inside the vehicle, enough luggage room here. Okay, so this is one set of work which the occupant architecture team is working on, defining comfort within this space here. Okay, once these positions are defined, and definitely a lot of benchmarking happens here, many OEMs try to give good space for the occupants sitting inside the vehicle so that they feel comfortable during long drives, is on the couple distance. The other aspect which also comes in is all about your head envelopes. So once your occupant positions are defined, the head clearances get defined. Now there is one aspect which most of the OEMs work with is the visibility aspect. As far as driver is concerned, for his eye points, we can define his visibility requirements. Okay. Now for the second and the third row, there is an interesting concept which comes in, which is called as a theater effect. I mean, most of you would have sat in a theater where between the first and the second row, they sit slightly up. Okay, so that the visibility of this person is better. Also, from an aspect of packaging, you will have a lot of space below, which will be demanding space inside. In a powertrain, you'll see a tunnel going here. Sometimes you'll have a fuel tank coming here. Sometimes you'll have a battery which is being pushed here. You'll have a spare tire and a suspension parts which will try and come here. Okay, so there is some interesting and very unique ways of getting space for other parts that I had mentioned earlier to you. Okay, so along the length of vehicle, this is how the comfort gets built up. Other important aspect is luggage room. Now, this also plays a very important role in terms of the customer's interface with the vehicle. A luggage volume nowadays is becoming an advertising element. Many manufacturers have started advertising good luggage room in terms of liters. Okay, so defining a luggage room and what gets into the luggage, what kind of, is it cabin baggages? Is it long distance travel baggages? Is it, golf carts? Is it something, computers, accessory, peripherals? It's something it's very important. You'll see a lot of people having unique seats folding down to increase the luggage room when this is not occupied. Okay, so these are aspects which have to be considered when you design this. Now moving to powertrain placement. Now, this is the most important aspect in a vehicle. After we have finished the occupant part of it and defined certain volume for the occupant, we now move to powertrain locations. Okay. Now, what I've shown here is where in the world, if you see a lot of vehicles, wherein the powertrain is placed. Predominantly, what you will see in most of the off-roading vehicle is a longitudinal engine, which is the engine faces from front to the rear, which is actually called as a north-south engine, and which drives the rear wheels. And in case of Thar, we also have something which is called as a four-wheel drive, which also there is a transfer case which drives the front wheels. Now, if you look at front transverse engine and front wheel drive, which is what we see in XUV 500, is all about engine here placed in the front compartment and driving the front wheels. Okay, so Thar, you will see driving the rear wheels and also the predominant drive to the rear wheels, and also an application wherein you can engage to transfer case a four-wheel drive front wheel also. Okay. There are other aspects of engines which are also coming in. You will see mid-engine, you will see rear engines. I have not taken those examples. I took XUV and Thar as an example to work on. Now, defining the powertrain location inside. Now, the powertrain, after we've done the occupant, it's important that we get into the powertrain aspect. So the powertrain now needs to get into the front space. So the functional attributes, performance is what drives. So if it's a 2.2 liter engine and a 6-speed automatic transmission, okay, that needs to be packaged. And that is what the market demand is for. So this is the package that needs to be put in. The key aspect here is that the engine then connects to the front wheels. I'm just talking about XUV 500. It connects to the front wheels. So if you see between the engine and the wheels, there would be an offset. Okay. And it's also important that we connect the engine to the front wheels by CV joints. Now, when you have CV joints coming in, you have to work through on the operating angles. So the experts who are working within Mahindra, there will be experts who will be working on the sizing and of this powertrain. There'll be experts who will be working on the CV joints. There'll be experts who will be working on wheels, tires, suspension, and steering. There'll be experts who will be working on the cooling modules, the HVAC, modules. So all of these are actually people who are trying to size their parts depending on the market demand of power and torque. Okay, so all of these are getting built into, so that the job of the architect is to ensure that each of this performance demand gets fitted into this spatial envelope. Okay, the demand comes in from a market that we need to have a good turning circle diameter. So that means the tire envelope is going to be kind of a slightly bigger envelope. You have a powerful engine, you have a very strong tire, a very big tire envelope, and you have to have a 5-star rating. So that means the rail which gets structured, which gets built in, needs to consider a size. Now, these are the challenges with which all experts work within an industry. Okay, so if you'll see here, we have to have some space here for crash protection. You have to have some space for how the engine operates during the torque, so there'll be dynamic movements, wheel connections, wheel envelopes. So this is what gets built up within the packaging space of a powertrain. When you see along why, like I said, again, your tire envelopes, feed system, this is where it comes in. From a manufacturing perspective, it becomes very important that the engine you are able to assemble within this space in the shortest possible time. It's very important. So manufacturing consideration is all about assembly times. Engineering considerations is all about minimizing the space requirements and trying to make it more compact footprint. And customer demand is power and torque, higher power and torque. So a kind of a trade-off which people are working with. Now, what you see here is a longitudinal engine. What you see here is a transverse engine. Ground clearance plays an important role in terms of, in the Indian context, it's very important that we give good ground clearance. But the moment you have good ground clearance, right, and very high suspension travels, your shafts which drive the wheels become very acute in angle. So we need to ensure that their performances are okay. Okay, so that is another trade-off that engineers are working with. So in this architecture, which is the powertrain architecture, a lot of functional attributes are being worked upon. Okay, now after we have done all the functional attributes and built up the volumes for them, we have built up what the occupant architecture demands were in terms of the space that was needed for the occupant. We all discussed about these two boxes right now. Okay. Now, the key dimensional aspects which come up in a vehicle is front overhang, wheelbase, rear overhang, and overall length of vehicle. You also have an overall height of vehicle, which is also very important in terms of, stability for a vehicle. Center of gravity also plays a very important role. You make people to sit up, you give theater effect, your vehicle height keeps going up. You start having higher and more powerful engines, they take more space, the bonnet and other things go up. So the driver has to see below, so his downward visibility gets impacted. Okay, so these are aspects which need to be considered. There is a demand for higher ground clearance, so we try and push everything up. So the space which is needed here keeps reducing because the dynamics guys are trying to push this down by saying that, we need lower center of gravity, we want better ride comfort and handling. So another set of trade-offs that people are working on. Then we come to the third box, which is all about the underbody. This box talks about wheels, tires, suspension, and the energy source. So the key aspect here is, in case of IC-based engines, vehicles, it is all about fuel tanks. In terms of electric vehicles, a lot of space here. In fact, the whole space here will be utilized by the battery. You have big size tires for all SUVs that need to be packaged. You have a lot of volume which is taken up by the suspension components and the rear drive systems. Big size tires mean a lot of travels for better ride and handling. So a good amount of travel has to be considered. So good amount of clearance gets built up. So all of this is now intruding into your occupant space. So the underbody packaging is another set of experts. These experts bring in their knowledge from the expertise they are building up over driving vehicles, refining vehicles, and what would be the key volumes that they need to achieve customers' comfort requirements. Okay, and also ensuring that performance requirements are not kind of traded off. For example, exhaust volumes. For NVH purposes, you need exhaust mufflers to be of certain size. You want fuel tank of higher capacities because you want vehicles to cover different long range. Battery, definitely you need higher capacity batteries. So underbody packaging is something which is, putting a lot of pressure on the volume which is needed there. And most of it intrudes into the occupant volume. Placing the occupant along Y. This is so that what we saw was this placement. Now this placement becomes important because your suspension travels, and ensuring that you place him so that you get enough space for all your suspension travels is something which is again critical. So with all underbody parts and suspension travels, everything coming in, you see a lot of this space has got intruded now in the occupant space. Okay, now coming back to your basic architecture of occupant, your basic architecture of underbody, and the basic architecture of the powertrain has kind of got, the volumes have kind of got developed. Okay, the other aspects which get worked through in the vehicle is all about controls. So when we saw the digital customer, the digital customer has, is trained for ensuring that the reach for gear shifter, the reach for parking brake, the reach for seat adjustments, the reach for, the combination switch on the steering wheel, the reach for, the mirrors. There are all of these reach aspects which have to be factored in, and so that the components can be placed inside the vehicle. Okay. The reach for your basically utilities, armrest. These are all comfort, convenience. All of this is getting built up within the occupant architecture part. Okay. The important aspect is also your visibility to the instrument cluster and the infotainment screen for different sizes and of people that are getting into the vehicle, the 5th percentile, the 95th percentile. Everybody should be able to see the cluster. Okay. Your vision zones, from looking up for the signal, looking down for clearances, looking on the sides for the curbs, are various clearances that this people sitting inside the vehicle would demand, and they are kind of built up through softwares and standards and the market demands. So whatever I just explained earlier, is I'm just giving you a glimpse of the overall process. So there is a market demand which is in terms of what the program is looking for or the customer demands are. So customer demands are for space, comfort, and convenience. Then we talked about driver occupant packaging. So the driver triangle, they're positioning all of the people inside, the controls, the reach for the controls, the space inside, the clearances inside, the headrooms inside, all of this, and also considering where you would want to place your product within the market, a competitive set, whether you want to be in the leadership or you want to be amongst leaders, is what gets considered and built up into the vehicle layout. What you see here is the very first vehicle layout which was built up for XUV500. Okay, this is how it looks like. So the considerations that we had in thought was approach, ramp breakover, ground clearance, and the departure angle. Step-in height plays a very important role is for a person to get and to be able to get into the vehicle without having to strain up, go up or go down into the vehicle. So an easy height to get into the vehicle. Space which is needed for the driver to operate pedals, comfort for steering, first and the second row, the probable openings for the door, depending on where these occupants are, his visibility requirement, this line to see the signal, traffic signal, this line to see the nearest vehicle below. These aspects are safety aspects which are built up in the vehicle. So you have frontal crash. So you need to protect some space here for the frontal crash, some space here for the rear crash. These are all your pedestrian safety protections which need to come in. So this is how a volume box gets built up when the initial vehicle is conceptualized. Now this spatial requirement is for occupants, the powertrain which is coming in here, and the underbody components which have demanded. So tire sizes, suspension, they all come in all of this space. Now what you see here is the line which I have drawn. Okay, these lines are nothing but what the emotion aspect of a vehicle is built upon. Okay, so I'll just go to the next slide and then come back here. This is how the emotion gets built up. So in a case of an XUV, the expectation of people of the the company was and the studio was that it is a cheetah inspired vehicle. Case of TUV, you see it was inspired by a tank, and Marazzo was inspired by a shark. Now, if you see, there are sleek elements which are getting built up here. Okay. In XUV also, there are a lot of sleek elements which are getting built up here. Because the cheetah, if you see this profile of a cheetah here, is something which is what is expected to come here. So now if I go a slide back, this is what the expectation of a cheetah is. Okay. Now, what happens is, these two people, for better visibility, we move them up. So the line for the style or the design comes something here. Now that's where the trade-off starts to happen. Okay, now, because he is the most important guy, but we need to have cheetah character also built in the vehicle. From the sides, if you see also, the vehicle would try to come this way. So from sides also, if you see, your shoulder room and hip room gets impacted. There's some orange boxes here. The bonnet seems to go, bonnet would most probably go up because the cheetah head is up. So it will impact his downward visibility. Okay. Now, the role of the chief engineer, who is working with all the experts within the product development domain, is to ensure that the compromises are not made to the emotion, as well as the compromises are not made to the function. This is how an automobile engineer's day would look like in an automobile company. Okay, which is emotions and functions. Okay, now moving down, after we have built up this model and the character of the vehicle has got also developed, each aspect, functional teams work through and built up sections. What you see here was just a straight line, but now this is roof. This is how that cantrell looks like, one part, which I explained in the anatomy earlier. And this is your curtain airbag. Okay. And what you see here is the head of the person. And from this head to curtain airbag, there is a dimension which is needed. Studio says you can't compromise on this because this is needed for cheetah look. This is needed, dimension is needed as a structural dimension for meeting your bending, torsional, and NVH requirements. This head is the actual occupant's head for whom the vehicle is getting designed, and you need a minimum clearance here. Okay, this is what is all this knowledge-based engineering requirements all about. Each expert is trying to demand his performance requirements onto the product, and the chief engineer's job is to ensure that he doesn't compromise in any of these, and also gets in all of the requirements with an appropriate technology, cost, and investment. Okay. After all of this process goes through each and every aspect, there are close to about 200 points in a vehicle which gets checked this way. Your basic vehicle gets ready, which is a 3D layout with all master sections and everything built in. Now, these are some things which are knowledge-based experiences that people have built in. After we built up all these knowledge-based experiences and share, then the bigger team starts working on, which is the simulations team, which you would have seen in the earlier presentations. Okay. The aspect which I was explaining about, you want more space inside the vehicle, but you want the vehicle to be compact. You want more fuel efficiency, but you have more number of seats and more weight inside the vehicle. You want upright sitting because you want better visibility, but you want minimum roll in the vehicle. You want car-like feeling and handling, but you want durability and toughness. You want a big car, but you want the ease of driving. So these are all trade-offs. And these trade-offs are what a chief engineer and the chief platform head and the cross-functional experts are every day working on. So this is what you see, a image of a Thar. It shows your chassis frame, the wheels and tires, the very high departure, ram breakover and approach angles, a good requirement for visibility, but a very high bonnet, which is there. Okay, so this is the basic architecture of Occupant, Powertrain, and Underbody, which has got built with all master sections and everything in place. The next aspect which comes in is the virtual verification aspect. So this model with all the master sections and everything is then simulated for NVH and structural simulations. Ergonomics and packaging, anyway, we talked about. CFD and dynamics, all about, coefficient of drag. A lot of manufacturing inputs coming, whether you're able to assemble the powertrain, whether you're able to assemble suspensions, you're able to get the cockpit in. Dynamics input, okay. Safety inputs, it's all about, crush space that we spoke about, pedestrian protection. It's all about, side protections that we need to do, rollover protections that we need to do. Design, anyway, we spoke about, how they are demanding in terms of what the shape should look like. There are a lot of legislative and regulatory requirements from each country. So if we want to make a global vehicle, there are a lot of legislation and regulatory requirements which need to be adhered to. Okay, all of this is getting into this layout. Simulations happen and a digital vehicle gets assembled in the digital world with meeting all targets with minimum of compromise. And this is what the chief engineers will try and do. And that is the job that they work on every day. Finally, what do you get? You get an architecture convergence to successful product. So what you see here was the process which was followed for Barazo, XV300, and Thar. And I've just put up some ratings here, which are for the safety ratings which these vehicles. So Barazo was a 4-star, XV300 is a 5-star, and Thar is a 4-star. The most important aspect of Thar is also the child protection is a 4-star, which is really commendable. XV300 is also 4-star. So, I mean, this is really a safe vehicle if you see from that perspective. Okay. So, in short, I have tried to explain to you how from an occupant who is a driver, he is sized considering different countries. He is placed in a vehicle. His requirements are built up. Around his requirements, functional attribute requirements get built up. Around functional attribute requirements, sectional and structural requirements get built up. And also the design aspects and elements which get built up. All of this gets virtually evaluated, virtually assessed, virtually the targets being met. All of these targets are virtually met. And then the physical validation happens. We get into productionization and then launch the vehicle. So This was all about how the vehicle architecture gets defined. Okay, now I'll move to platform definition very short, in a very crisp manner. So what do we mean by platform? So one important thing that we saw in a platform definition in the manufacturer's requirement was to ensure that we use, the product for multiple applications. Okay, so what is a platform? So a platform is nothing but in a vehicle. Okay, whether it is a body or frame vehicle or a monocoque vehicle. Okay, it's all about ensuring that your dimensional bandwidth, which is all your wheelbase, wheel tracks, how on one platform you can get multiple dimensional bandwidths. Okay, performance bandwidths, design bandwidths. You could have on one platform multiple vehicles like this, modules, and also manufacturing commonality. Why do we need to do this? So that the manufacturer's focus is to reduce investments, produce products from one common base. Okay, I mean, the example which comes to my mind is all about in the Indian restaurants, if you see, is all about the batter which is used for making idli, dosa, and vadai. Okay, the batter is actually the platform. Okay, your dimensional bandwidth is in terms of what different sizes of dosa, idli, or vadai that you get. Okay, your performance bandwidth is in terms of how you vary the taste, you vary the offerings that you get there, right? Your design bandwidth is all about how you present it. The dosa gets into different shape, the idli gets into a different shape, the vadai gets into, you can shape it differently, you can make it to look different. Module commonality is all about logistics. I mean, if you see a person in a restaurant standing there, you ask him about a different variety of dosa, he has modules in front of him. He just picks and places, assembles and gives it to you. Right? So there are some modules which will be very common. For example, your sambar and chutneys is a very common module. Okay, what is varied is the dosa size, the dosa offering. It could be masala dosa, ghee roast dosa, plain dosa, uttapam. This is how you vary it. Manufacturing commonality is what he uses to make it. Okay, so for example, he has one hot plate in which he can do this. There is a steamer for the idli, right? So this is what bare minimum is needed. So for a manufacturer, it's important, that with a minimum common space, he can make multiple products out of it. Now about Mahindra, how is Mahindra doing this? So if you see Mahindra latest Thar, which has come in, all new Thar is on a 3G platform, the third generation platform. We also have the Scorpio on the third generation platform. We have the TUV also on the third generation platform. Now, if you see the modules, you have a common chassis module. There is a variation in your wheelbase for all these vehicles. Okay, there is a variation in the wheel tracks. Okay, powertrains are different, so your performance can be made different. Your tire sizes are different. But if you see, the top hats are also different. But your basic frame kind of comes in from one aspect. So it is something which is common. Now, I'll move to the another platform that you have is the NGCS platform, on which we have is Bolero. It's called a body over frame platform. This has multiple offerings, and that's what many manufacturers would want to do. Okay, so there is a first generation Thar on that platform, there is a Bolero on that platform, and there is a Bolero pickup on the platform. Again, same way, multiple engines, multiple suspension types, a lot of things which are made flexible, fixed. Okay, so if you see how the platform gets built, now this is one dimension from your wheel center to the accelerator pedal point. This is your Powertrain architecture. This is your occupant architecture. This is your underbody architecture. Okay, which is getting into the. So if you see here, this dimension has been fixed between most of these vehicles. What is varied is your front overhang, your rear overhang, and your wheelbase. So what you see is 4 different products on one platform. Okay, so when you make your architectures, the focus is to have, to build up these kind of offerings. So you can be in an SUV segment, maybe a minivan segment, a pickup segment. Okay, a lifestyle pickup, a commercial pickup, a small SUV, and a slightly bigger SUV. So you have 4 different segments coming up on one platform. Okay. Thank you. So this in short was a little bit about architecture and platform. We could take up questions now.
Prajot will be moderating the session now. And before that, I just like to have an announcement. Prajot, can you hear me without any disturbance?
So there is an echo.
Okay. But I don't know, but still, you see the forms, the Google Forms will be, the link to the Google Forms will be given in a short while from now. The people, as you know, the people who attend all the 5 sessions will be eligible to get a e-certificate. So you people should, remain in this workshop till the end, and then fill the forms, and then you can, give your opinions on that. Mr. Prajot, you can now moderate.
Sure, sir. Thank you very much, Samir sir, for the wonderful session. It was very insightful. I would like all the participants here who have been attending this program to put up how did they like all the examples which Samir sir has shared with us, and put down their questions here in the chat box so that we can take them up one by one without actually leaving them any. So Samir sir, I have one particular question coming up. Basically, you have talked about the anatomy of the vehicle system, as well as the platforms. So when we develop the basic part, that is the chassis of a vehicle, do we keep in mind the entire different vehicle systems or different types of vehicles which we are targeting for a customer?
Yeah, that's a very good question, and it is important. For example, in Bolero, if you see, it considers CNG also. It considers regular fuel also. It considers different type of suspension. It considers different type of powertrain installations. Yes, we have to consider, because this is one aspect where the whole platform is thought through. Where all would we want the vehicle to be placed, what all are the customer demands in terms of powertrain, in terms of tires and suspension types, okay? And it's also in terms of fuel types. And all of these have to be considered in the frame design, in addition to the other requirements which come up: ground clearance, step-in heights, approach departure angles. All of these things are very important. They are considered, and you have to prepare for future. So these things are considered.
Yes, sir. So there is a follow-up question on this. So when we look at a particular vehicle for different countries, so having this platform in place, can we use this platform structure to target different customers at different countries with different body built according to the presentation which you shared?
Yes. So this is what many OEMs do for a local market. Okay, I'm just giving an example for a domestic market. Okay, one of the important aspects is to meet the domestic market's requirement in terms of legislation. Okay, so maybe in the context of India, we just need to meet 56 kmph offset deformable barrier. But when it gets to a global market, the speeds increase and it moves to 64 kmph. And when it gets into another market, the speeds further increase or the requirements change. So what happens is, when you design a vehicle, you try and keep the geometry of parts same. That is your sections, the section modulus. You try and build it up to a level where it can be scaled up. It can be scaled up by using a different material and a thickness for an XYZ market, which is a highly developed market. And any developing country, you could use a different set of material and thicknesses. So you could, where you normally build it up this way.
Yes, sir.
So yes, and many OEMs do this, and we need to, in a sense, because with little investment, you need to actually get in more volume. So this is what is the prime focus of many automobile engineers, architects.
Yes, sir. So there is one more question which we have is, can platform structures be used for both IC engine vehicles and electric vehicles in a crisscross manner?
We can do that. I mean, currently, if you see many OEMs, the first step that many OEMs did was to actually convert their IC engine-based vehicles to electric vehicles. Okay. Now, the key aspect here is, since the vehicle got configured the way I explained for IC, the efficiencies were built for IC engines. Now, in an electric vehicle, what you need efficiencies is for the prime energy source, which is battery, okay, which then becomes little difficult to package. So you compromise on range then. So the future is, if you see what Tesla's and everybody else is doing, is actually, design the vehicle around the battery. Whereas in an IC-based vehicle, you design a vehicle around the engine and its drivetrain. Okay, so that's the difference. So you have adopted EVs, but they are inefficient, right? And weight also becomes on the higher side because they were designed for IC based. So the basic weight, the section, the strengths would have been designed for an IC based vehicle, structure, NVH, everything. So in electric, weight is more important. So materials would be different. So these will be certain inefficiencies which get built up in a IC based vehicle if you try and make it electric.
Yes, sir. Sure. Thanks for the answer, sir. We have another question. What are the impact of BOF and monocoque platforms on the cost of the vehicle?
Oh, interesting question. Okay, so monocoque vehicles have the chassis or the structure which is integrated into the body in white. Okay, so they are more efficient in terms of material usage and weight. BOF vehicles that way have a separate frame and the body gets assembled on a frame. So the weight of a BOF vehicle is on the higher side. Okay, so from a cost perspective, BOF vehicles will be costlier than material cost wise than a monocoque vehicle. Okay, but from a durability perspective, from like if somebody wants to make a rugged vehicle, then frame becomes important. Somebody wants to make a more efficient vehicle in terms of performances, then I think your monocoque vehicles become more important. And in case of a monocoque vehicle, the difference in cost you could use for other features built inside the vehicle.
Yes, sir. So there is there are few questions which have been spanned over a wide area. So I'll try to condense them into one question. The question is, with platform structure and advanced engineering approach, are we moving towards a module structure where a customer can choose different modules and customize his style?
Okay, so in terms of the basic platform, okay, the modules are kind of fixed and available as a product offering to the customer. For example, you can have a diesel engine, a gasoline engine, automatic transmission, manual transmission, four-wheel drive, all-wheel drive, different sets of tires. So these are the kind of, variability which gets built up in the platform. Okay. So these modules are available in the product offerings that you have. So if you see Thar has this different modules which is available. There's another module which is your occupant structure, wherein you can also build it up in terms of the accessories and features that you need to build up. Some of it comes factory fitted from the company, but most of it, some other part of it can be built up through accessories. But I haven't seen a vehicle OEM who is kind of building up modules for customers within the plant. right? It is either through the variants that the manufacturers release, which is in terms of the powertrain variants and the trim variants. Over and above it, I think most of the modules get built through accessories.
Yes, sir. So the next question which we have is with this platform and ground clearance, with this platform structure, can ground clearance be changed after the design?
Ground clearance can be changed after the design. Okay, interesting question. Yes, ground clearance can be changed. I mean, it can be definitely increased and decreased, but it impacts ride and handling. It impacts, it's all about where you place the vehicle. You can lift the vehicle up after you have designed a suspension, right? So it can be done, and many off-road enthusiasts where people do this on their vehicles, but not as an OEM. Not as an OEM, it is done as an application, but can be done. It's where you set your ride height at.
Yes, sir. So the next question which we have is how the design bandwidth is carried out in any industry perspective. Can we get
Okay, so
clarity on this?
if we see our Thar, TUV, Scorpio, and on the 3G frame is actually a good design bandwidth which has come in. But this is Mahindra example. But if you internationally, there are many more examples. If you see Volkswagen platform, they have platform which is built across brands, platform which is built across segments. So they share platform between Skoda, Volkswagen, Audi, so they built it up across brands, across segments, across offerings, and change their top hats. They make distinct looking vehicles on same platform. Very differently, distinctly looking vehicles on the same platform.
Yes, sir. That was a very good example for understanding. We have another question. Does tire size affect the efficiency of a vehicle?
Okay. See, tire in terms of the bigger the tire size, the weight of the tire goes up. Okay, so definitely it impacts on your resistance. The weight is it's actually an unsprung mass. So that way, your suspension and other efficiencies get reduced. I mean, you are impacted, not reduced, are impacted. In terms of performance, maybe fuel efficiency, there'll be a marginal improvement. Okay, that could be seen. So tire sizes do impact in terms of certain efficiencies.
Okay, yeah, yes, sir. So the next question which we have is, when we design a 7-seater vehicle, what is the consideration? Is it the comfort of the passengers or the luggage space which we have to incorporate either on the roof or within the vehicle?
Okay, so it all depends on the application, like I was explaining. If it is an MPV, multi-purpose vehicle for a minivan kind of a vehicle, luggage plays a very important role because these vans are used specifically to carry people and their luggages. Okay, so both play a very equally important role. And the segment that you try to get in and the competition that you have there, you try and be in the upper percentile in terms of meeting the the market demand. Now, in terms of an SUV kind of a vehicle, the more focus will be on the persons who are sitting inside the vehicle, right? And it's not that the focus will not be on the luggage, but MPV will have a higher focus for the luggage room. An SUV may not have equal high weightage, but slightly higher weightage. But to manage within a given space appropriately the luggage and what all needs to get in is the key. In a customer segment, you would only want cabin baggages to get in. But in certain customer segment, you would want really long distance travel bags to get in. So these are aspects which need to be thought through. And if all seats are occupied, because in an MPV, all seats are occupied, right? So when all seats are occupied and you need to have luggage. In an SUV, not necessarily all seats are occupied. You would have the first and the second row occupied. So you could fold the third row seats and give a bigger luggage. So this is how the variations are built up in the vehicles.
Yes, sir. So the next question talks about what are the similarities or differences in case of two-wheelers, tractors, or cars with respect to platform structure.
Okay, each product has a platform structure. Okay, tractors also have a platform structure which is built up on the powertrain. Three-wheelers, two-wheelers also have a platform structure which is built up on their chassis. Okay, so the platform structure is nothing but your basic, skeleton on which the vehicle gets built. So how do you configure the skeleton for multiple requirements in terms of performance, in terms of size, is built up in each platform. So if you will see that tractors also have a platform, two-wheelers and three-wheelers also have a platform. So their structures are also built up around platform.
Yes, sir. So there is a follow-up question on one of the previous questions which we have already answered. So when we consider electric platform vehicle, is it possible to incorporate IC engine vehicle in that platform if there is a need base?
See, as a, I mean, it's not that it can't be, but if it's designed for electric, okay, and then you want to put an IC, okay, it can be done, but then it would impact the platform in terms of certain changes, and they may not be efficient for either or. It can be done, but the changes which need to be done to the platform may not be efficient either for electric and for IC based vehicle.
Yes, sir. Yes, sir. There is one interesting question which is coming up from the perspective of an engineer. So what are the skills required for an engineer in order to switch from mechanical engineering concepts to electrical vehicle engineering concepts? Any particular course which they need to undergo, or any particular software which they need to learn?
Okay, yeah, very interesting. So, I mean, if I only speak from an automobile perspective, okay, the two things which come to my mind is one is the battery and second is the motor. Okay, these are mechanical components supporting electrical requirements. If you see motor, it's actually a mechanical component, but having electrical function. If you see battery, it's a mechanical component having an electrical function associated with it, right? These play a very important role because future is electric and the structures of these two parts play a very important role. For example, a battery structure is nothing but a structure which is integrated into the body so that, the various safety requirements are built up. So from that perspective, a mechanical engineer can work in a battery organization, a company which makes battery, to work on structural aspects, right? So could be one way of looking at it. The second way of looking at it is, now moving from structure, then we move to say in terms of efficiencies that they need to work through, right? So there is a lot of, circuits and other things which get worked upon in the battery as well as in motor, right? Where a lot of components which are used in are metals. You use copper, you use magnets, so there's a huge demand for such people. If you focus on materials, you could still work for electrical companies, right? Electrical component manufacturers.
Yes, sir. So any suggestions from your side for students? What should be their master's choice if at all they go for one? I know this is a biased question, sir, but yeah.
I mean, okay, I'll be very open here. So what's happening in the world today? The innovation, where is the innovation coming in from? The innovation is coming in from, I believe the innovation is more coming in is from materials, because that's where the shortage is going to be in future. Talking about lithium, we are talking about, the other cobalt and the other materials that are needed. Okay, so I believe that the innovation in the area of material is going to be very high focus one. The second high focus is going to be, in the area of, I believe, robotics. That is what I see coming up. The third area which I see is space exploration, and definitely material comes in there, propulsion systems comes in there, a lot of electronic systems are coming in there. So, and the most important, if somebody is not into core, and which is also in a support, is the data analytics and your artificial intelligence. That is also something which is very strongly coming up.
Yes, sir. So I'm going through a lot of questions here. It's been like a free flow of questions which are coming in. It's getting really hard for us to answer all of them. There is one more question which talks about aerodynamic drag. So how do we incorporate this factor when we are considering a vehicle from platform perspective? So vehicle drag will change for every new design. So how do we incorporate this?
Yeah, so this is a very good question, and I kind of showed an image when I was working on the presentation which I took the people through. See, when I was working on the Marazzo project, and we got a focus, because it was an MPV good. It needed to have a good fuel economy, and also it needed to have a good coefficient of drag built in. Okay, so the key aspect here is to get the aerodynamic lines, built up very early in the design. And there are a lot of softwares nowadays. I believe in the CA simulations, these softwares would have been talked about. So there are a lot of softwares, and there are a lot of experts in this area. So as you are sketching a line, okay, you get to know the impact of that line in terms of how it performs for various your drag requirements, in terms of at 90 kmph, 100 kmph. What do you see? Where do you see resistance? Where do you see the flow separating? Where do you see the drag forces increasing? How do you smoothen the line? So a lot of work went in. If you see, Marazzo is a very aerodynamic shape. Okay, and the aerodynamic, I believe, was 0.36, 357 or 0.36. Okay, so how it was achieved was, the shape was worked through diligently. As the occupant architecture was being worked upon, the powertrain package was being worked upon, the top shape of the vehicle, the sides shape of the vehicle, the features that we need to give, allowing air to flow smoothly all around the vehicle, it's a science by itself. So the two teams, the emotion teams which work on the art part of it, they want the shape to look like a shark. It is aerodynamic. It is very sleek. And the engineers, which are more of who are using the simulations and who are working at, whether the sheet metal can be formed, whether that shape can be given, they are more of a scientific, logic-based. Both of them work together using very good softwares nowadays which are available. Okay, and also you make scale models, you put them inside your wind tunnel, you start assessing things, you start modifying, you give shapes to parts so that you allow more flow to smoothen out. So a lot of things, a lot of work goes on, and it happens for most minor products. Marazzo, I can give is a very good example where it was done.
Yes, sir. So there is another interesting question which we have got. What is the scope of 3D printing in advanced engineering and platform structure? Do we only use it for prototyping, or is it an opportunity for final end product as well?
I see right now, worldwide, I have seen that this is also being used for where there are small volume cars, this is being used for production aspects. Your high-end supercars, you make only 50, 60 or 100 vehicles. This is being used for production aspects. But when you look at, the current context that we are working through, lot of our virtual simulations and lot of our building up correlation between the simulations and the actual test. You use 3D printed parts and you build vehicles, you make sitting bugs, you make package bugs, you make models, you assess air flows, you assess thermal aspects, you assess, shapes so that you get better fit and finish, better perceived quality. So this is being used extensively, 3D printed. And also for proto parts. And somehow during our proto builds, we use, when I say a headlamp, for example, housing comes 3D printed.
Yes,
very
sir.
good RPT processes which are being used in the industry nowadays. And it helps a lot.
Thanks, sir. Thanks for that answer. We have another interesting question which talks about front powertrain four-wheel drive or rear powertrain four-wheel drive, which is more efficient and more easy in terms of design, also with respect to the customer.
I'm sorry, Prajot, I didn't get your question.
Yeah, so basically the question is about the front wheel drive and the rear wheel drive, which is more efficient and more easy in terms of design as well as safety aspect for customers.
Okay, both are okay. Both have an equal pros and cons. Front wheel drive vehicles is basically more for MPVs and more efficient cars. A rear wheel or a four-wheel drive vehicles are more off-roading vehicles and more commercial type or pickup trucks and those kind of vehicles. You'll see a lot of so it all depends on the application that you are designing for, and for both the applications it's a challenge in terms of safety. If it's a front wheel drive car and if it's a high powered engine, you need to consider a big engine in the front. So definitely your crash requirement, crash space, and the sections that you need to use, right? All are kind of, puts a huge pressure, and size of vehicles become bigger. So that is one problem there. And if it's a lengthwise engine, which is driving the rear wheels, you have a tunnel built inside the vehicle. Your crush space reduces. Okay. So that also is a huge challenge in terms of safety. So both have an equal, play in terms of, but there are unique solutions that all automobile engineers work through and ensure that, the basic aspects are met.
Yes, sir.
But applications are different.
Yes, sir. So with time crunch, we can consider only one last question, and this is an interesting one. With respect to hydrogen vehicles also competing with electric vehicles, how do you see the future of Indian automobile market?
I very recently read that our chairman has been on the committee for that hydrogen. We did make, some time back a vehicle. I mean, yes, hydrogen is available in abundance, so seems to be interesting. How do we get that technology in and make it available is what everybody needs to work through. I think it's a very interesting technology. EVs is not as efficient as it seems now, but over a period of time it will. But for EVs also, if you see the wheel to well cycle, that means they are crude to the wheel, right? That cycle, if you see, it's not efficient yet. Electricity still gets produced in India on, we are moving towards, but a higher percentage of it gets through coal-fired furnaces, so which is also a higher pollution. So EVs themselves are not as efficient as they are. It's only the operating cost which is low, but the way the electricity is getting generated. Hydrogen is hydrogen is something which is, you can say, looks lucrative. I mean, we need to work through.
Yes, sir. Thank you very much for all the elaborate answers. I tried to condense all the questions into as many questions as possible, which we can answer in this time crunch. I guess we have done justice to all the participants here answering those questions. So over to Wales, sir.
Thank you, Mr. Prajot. As usual, you have done a very good job of moderating. It's not an easy job to to juggle so many number of questions. You have very effectively satisfied almost all the participants. Because even though we don't have time to get all the questions, but of course the essence of all the questions I think you have posed effectively to Mr. Samir Rawte. Mr. Samir sir, of course you are as usual, because I think it is the G of the Mahindra and Mahindra, how to keep the students engaged. You people have the magic of engaging the people. Even, of course, to be very frank with you, I'm not coming from engineering background, but still, whatever you spoke, whatever knowledge you have shared with us today, and especially about the dream vehicles like Malazzo or SUV 500, of course, we are stuck to the seat. We are glued to the seat. And thanks for sharing all the, all the complex principles in a simple manner. And we also have Dr. Mr. Shankar Venugopal, and who was our special speaker last Saturday. And I invite Dr. Shankar to give his valedictory note.
Thanks, Mr. Wills. Thank you so much. It's my pleasant responsibility to thank everybody who made this event possible. I should definitely start with the expert speaker of the day, my good friend, Samir Rawte, who could condense his years of rich experience building some of the most innovative vehicles over the years. He could condense all that into just this 1 hour, so which is really mind-boggling. Because when you have such rich experience, you have so much to say and you don't know where to stop. But he was able to really put this together in just a 1 hour presentation and share all those rich insights with you. So I should thank Samir first. Thank you so much, Samir, for taking your time and sharing your knowledge with all of us today. And of course, the other 4 speakers. Last week, I had a chance to speak. So I want to thank the organizers for giving me an opportunity to speak on creativity and innovation for automotive engineers. That's a topic very close to my heart. So I thank for the opportunity. Then the previous week, we had Dr. Akela Sharma, who spoke on the importance of simulation in automotive, touching upon topics like crash, lightweighting, NVH, the whole gamut of topics that he could cover. So thanks, Dr. Akela Sharma. And the week prior to that, we had our friend Naveen Chopra, who spoke on co-creating automotive product development through platform, people, and process. So thanks a lot, Naveen. And this takes us back to the very first talk in the series, which was on the 16th of Jan, where we had our friend Mike Smith, Mr. Michael Smith, who actually spoke from the UK, and he spoke on e-mobilities and the future. So I want to thank all the speakers for putting the effort to put together a very nice, simple, very insightful presentation and sharing their rich knowledge with all of us. I think it was Einstein who said that if you cannot explain in a few simple words, then you have not really understood fully. And the process of creating these presentations and making it, all of us really felt that this whole exercise vastly improved our clarity, and we could also consolidate all the years of learning into something crisp. So I want to thank the Vikatan family for giving us this chance to do that. Otherwise, when we talk internally, we assume that the other person knows, and then we directly jump to the topmost level. So we don't have the time and patience to go to the fundamentals and build from there in a day-to-day conversation. But in this series, we could actually do that. So this is very important for me to thank Mr. V. Srinivasan, the entire Vikatan family, and Mr. Wales and his team, few of whom I know, like Padmanabhan. There are many others, I'm sure, who have been working behind the scene for this flawless execution of this program. This is really hassle-free and very systematic and so structured and perfect. And I want to thank our automotive global product development leader, Mr. Veluswamy, for really conceiving this idea and coordinating and making sure that this whole program is designed to make it as effective as possible and the maximum knowledge share happens. So it is his vision that made this long event possible. So I'm sure there are many, many others who have been responsible for making this successful. Since I do not know everybody, I would just thank each one of you. And of course, I thank the audience, or the students, faculties, the young professionals who have prioritized this and spent their weekend time actually being with us. The kind of questions that we got at the end of every session was so insightful, so thought-provoking, and we felt really happy to answer those questions. So, of course, this is the whole thing doesn't end with this. This is just the beginning of a much longer interaction that we would like to have with both the Vikatan family and also all the young participants who have been the heart of this whole program. So Vikatan, I don't know for those of you who are attending from other parts of India, Vikatan is very, very popular, and it's almost there in every house in South India, in Tamil Nadu. I grew up reading Vikatan, especially the jokes I used to like a lot. And over the years, wherever I was, I used to make it a point to get that Deepavali special issue of Vikatan, which is full of interesting articles and jokes and whatnot. It's a delight, and it's a collector's edition item to have one every year. So it's a very strong, strong household name, Vikatan, and it's so nice to associate with Vikatan on this very important topic of knowledge sharing and preparing ourselves for the future of automotive. So I feel so excited about it that I also want to share one more information. Having heard all these things, I'm sure you'd be curious to see how all these automotive technologies are being developed and how the automotive products are being built. So it's very natural that we have triggered your curiosity more than what it was a couple of months back. So to further fuel that curiosity, what we want to offer you is also a visit to the prestigious Mahindra Research Valley. We call it as the Temple for Creativity and Innovation. It's a place that's so dear to us. We want to host you all to this Mahindra Research Valley. So as the Dean for the Mahindra Technical Academy, I'm going to really plan this visit so that you will get the maximum out of the day that you are going to spend at the Mahindra Research Valley. So I want to take the support of Mr. Wales and his team to plan this out so that a group of you can come over to the Mahindra Research Valley, spend time with us at the Mahindra Technical Academy, and look at how we build these technologies and how we build the future products. This is our, we are very excited about hosting you all. Of course, we have to wait for all these COVID-related constraints to go away once the vaccines are in place and when it becomes safe for you to travel and safe for us to host a group of you. We would love to do that. We are just waiting for that to happen. The earliest opportunity, we would do that. And so please stay in touch with Mr. Wales and team so that you don't miss that opportunity. And for those of you who are out of town, maybe I would tell you also it's worth actually traveling and being part of this group. So please do stay in touch with the Vikatan team and plan this out. Okay. So thanks a ton to every single person who made this event possible. And of course, I want to thank to Milis, who has been with us week after week, planning and coordinating this in such a systematic way. But for Milis, it wouldn't have been possible. And every week we had a facilitator. For example, my session was facilitated by Prajot. And I'm sure today also is Prajot, I guess. And thanks, because the Q&A part, facilitating handling, is a very important task. I think they did a great job of doing that. So I want to thank our HR leader, Jose, for lending support to this event through all his team members. And with this, I wanted to wish you all the very best. And the automotive world, there are so many interesting things happening with new technologies, products, and innovations. So this is just the beginning of the journey. There are a lot more exciting things ahead of us. So please stay connected, stay in touch. We will all work together to create this future, which is a sustainable mobility for the future. So all the very best. Thank you, sir. And I will hand it over to you, Mr. Wales.
Dr. Shankar, sir, I think we are very grateful to you because, we never expected this pleasant gift from you. I think our students really deserve that. Certainly, I think we have a very huge task of selecting, from this kind of group. I think we will do justice to it because, we have all the Google forms in which the people have already given a lot of answers. And there are a lot of questions which will help us to decide on who is a selected few, and based on the attendance, and we'll devise some ways and means, and then we can communicate with them. Certainly, sir. So it's a very great gift. I think our students will certainly make use of this. It's a once in a lifetime opportunity. I think whosoever attended this workshop, the 5 days workshop, I'm sure their life is changed. And those of you who is going to attend or visit the MRV, their life will be will go to the different trajectory. I think this is a God sent or Mahindra sent gift to each and every one of us, and especially for the students. And thank you, Mr. Samir, and thank you, Mr. Shankar. And I invite Mr. Majid Khan, our head of the strategicals, to give you a vote of thanks. Mr. Majid, sir.
Thank you so much, Wales. And thanks again, Samir and Dr. Shankar Venugopal for an amazing session. It's been about 5 weeks of awesome interaction with the Mahindra team and leaders. I would like to extend my thanks and gratitude to Mr. Velusamy, Head of Product Development, Mr. Michael Smith, Mr. Naveen Chopra, Mr. Akhilesh Sharma, and today's session, Mr. Samir Rawte and Dr. Venugopal. And also want to thank Prajot and Mr. Samson Jose, who have been moderating the session and managing all the questions that are coming up from our readers and shortlisting them. And it's not been easy because our readers have been very interactive and something we've not seen this kind of an engagement before. So thank you so much, Prajot and Mr. Samson Jose. Just to go back 5 weeks back, we had about 16,000 entries for this session, which is massive. This is something we didn't expect. And this wouldn't have happened without our association with Mahindra. Thank you so much. And I'm sure our readers and the participants have benefited immensely with the knowledge passed on by the Mahindra team. And thank you so much again, Dr. Shankar Venugopal, for extending this session and inviting our participants and readers to the Mahindra Research Valley. Thank you so much for that. And also thank you so much, Wales sir, Motor Vikatan team, and the Vikatan events team for putting this show 5 weeks without any glitches. Thank you so much for that. It's been a great session and looking forward for much more partnerships and associations with the Mahindra team. Thank you so much, sir.
Thank you, Mr. Majid, sir. Thank you very much. Thank you, students. Students, without you, without your support, without your participation, and without your interest, without your questions, this program would not have been this much successful. And thank you very much, students and participants. And certainly, you can wait. You can wait for the email from Motor Vikatan about Mr. Shankar Sah's announcement. Some of you are going to get some of you who are going to get selected are going to get a special pass, a special visa to visit the Mahindra Research Valley. That will be done based on the attendance. So attendance is more important. Now you have already given the Google form. as usual, what you need to do is you need to fill up the Google form. And then, of course, those of you who attended all the 5 sessions and filled all the 5 forms will be considered for the visit to the MRB. And thank you very, very much. And thank you once again to Mr. Miles. And without him, I think he is the one who is very instrumental in putting every one of us together. And Mr. Bala sir, the Bala sir is always, behind the scene. He has also played a very crucial role in this. And apart from this, of course, right from Velu sir to Mr. Shankar and Mr. Samir sir, and every one of you, Mr. Dr. Shankar sir has shared his association with the Vikatan and the Vikatan's jokes. And of course, I think he's an ardent trade of Vikatan. We are very happy that, people like Shankar are here, to propagate about, the old values of, this part of the country to the entire India. And of course, we are going to, along with Motor Vikatan and Mahindra, certainly will ignite the passion for science and automobiles. And thank you once again in another program. Thank you very much, sir. Thank you, everyone. Thank you.
Thank you.